Today we're going to be working on trig equations and solving them. So we have just this basic worksheet, which I think is absolutely brilliant. Again, my worksheets will say my name at the top. So this one I just pulled off from the web. And I'm going to show you the answer key here in a moment. I do have to say I was going rather quickly on some of those answers. So if you notice that there is probably a discrepancy, that's probably because it was my error. So when it comes to solving your equations, now this specific one, it wants your answer to be between 0 and 2 pi. And I would like it better if it was not including this 2 pi because we don't want to double include the same value. So I'll do the odd ones here. So these odd ones, and therefore you guys can practice these even ones. So when we approach these problems, think about it less so as a trig function and more of just a practical equation. So if we had something like x plus 2 is equal to 3, what would you normally do? Well, we would normally subtract the 2, therefore x is equal to 1. So same idea here, subtract the 2. You now have sine of x is equal to 1. Now you have to evaluate. So kind of thinking what we did from your inverse trig, except this time we're not working with an inverse function, right? Instead, we just want to know, hey, what are your x values that support your range of 1? Well, on your unit circle here, where sine is equal to 1, this is all the way at the top at pi over 2. So this is when x is equal to pi over 2. Now, if it just wants that first revolution and no repeats, we can leave it there. If it asked us for all solutions, in order to get that coterminal angle, we would just get pi over 2 plus 2 pi n or 2 pi k, where n is going to signify any number. So this is if we are asked for all solutions. We can just get that coterminal by just rotating about your unit circle. Let's try it again here. So again, just approach it as you would for x plus 8 is equal to 0. Well, first you might subtract the 8. So let's go ahead and subtract the 8 over here. So then you get 4x is equal to negative 8, or in our case, 4 secant of x is equal to negative 8. Then we would say, okay, well, maybe we divide by 4. Therefore, x is equal to negative 2. So for us, again, divide by 4. So now we're at secant of x is equal to negative 2. So thinking about now what we know about secant. Well, secant is 1 over cosine of x, meaning we really have 1 over a negative 2, or 1/2. So for us, and this could be cosine of negative 1/2, which on your unit circle here, looking at where cosine is equal to 1/2, that would be here at 2 pi over 3. And again, at 4 pi over 3. So your x is 2 pi over 3 and 4 pi over 3. And again, if they're asking for all solutions, we can just take those two solutions and add 2 pi n. And because this is your reciprocal, right, 1 over cosine, we'll take this response and do 1 over this response as well. So now let's try it one more time. So again, what would you do here? Well, let's go ahead and add your 9 root 3 to the other side. So you have 18 cosine of x is equal to 9 square root 3. Divide each side by 18. We get cosine of x is equal to the square root of 3 over 2. So now let's figure out all of the values, all of your radians when cosine is pi over 3. or sorry, root 3 over 2, my apologies, root 3 over 2. And a positive one at that. So this is at pi over 6. And again, at 11 pi over 6. Now, hopefully you guys can pause the video and try out 4, 5, and 6. Now let's take a look at these ones over here. Again, I'm just going to just roll right down, and then we're using the square root method. So look at all of these now. They have a square term on it. So we're going to do the same thing as we did above. We're going to treat this as if it was x squared minus 1 is equal to 0. Right, well here, this one actually being a difference of squares, we could say, well, this is really x plus 1 and x minus 1. Or we could just say, okay, well, this being x squared, I can add 1 to the other side and then take the square root of 1. But keep in mind, every time you make the square root, we do have to account for both a positive and negative response. That way you can clearly see that you do have these two functions or factors, there we go, broken up. Same thing here, wherever x is equal to a positive or a negative 1. For here, you can set them both equal to 0. And you can see where x is equal to negative 1 and x is equal to positive 1. So same idea applies here. Now we're working with a secant. So we could say secant of x minus 1 and secant of x plus 1 is equal to 0. Or add the 1 to the other side and you have this sort of variation. So now let's take a look where secant of x is equal to 1 and secant of x is equal to negative 1. This is again where we have cosine is equal to 1, or 1 over cosine, I should say, is now equal to negative 1. So this will only happen on your unit circle up above here, where your cosine is your x value. So from 0 radians, or if we're looking at negative 1, we're looking at pi. And again, we're just going to be looking at your angles between 0 and 2 pi. And this one, notice how I did the uninclusive. If we actually kept it like that as well, you could say that x is equal to 0, x is equal to 2 pi, and x is equal to pi. Again, if you wanted to add all solutions to it, all you have to do is just add a 2 pi n to these values. Let's do it again here. Again, treat this like you would 2x squared is equal to 1. What would you do here? Well, we would divide by 2. So x squared is equal to 1/2. Then get rid of your square root, or your squared, by taking the square root on both sides and accounting for both the positive and negative half. So you're left with the square root of 1 over the square root of 2. And I should maybe do this over here. Which back in chapter 2.2, we talked about how to split them up and rationalize. So rationalizing will multiply by itself on the bottom. So x is equal to root 2 over 2, and both the positive and negative half of those. So for us, we're really looking for, again, that same idea, but for your cosine to be at root 2 over 2 and negative root 2 over 2. So these are all of your pi's over 4. So we have pi over 4 here for your cosine. That's a positive 1. We have a negative 1 at 3 pi over 4, a negative 1 again at 5 pi over 4, and a positive 1 at 7 pi over 4. So we can include all of those within our response. So x is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And for those curious as to how we can write all of them, write all solutions, notice that directly across, this is in terms of pi. So you could take this pi over 4 and just instead of adding 2 pi n, we can just add one rotation above pi. So to go from here to here, we could just add pi n. And then again, we can take this one, 3 pi over 4, and add pi n to get to this next position. So that is if we wanted to get all of your solutions here. Let's try it one more time. So we have 3 tangent squared of x. Let's go ahead and add 9 to the other side. Divide by 3. So we're looking at tangent squared of x is equal to 3. Now we can go ahead and square root both sides, plus or minus 3. So now we're looking for where we have the square root of 3. So it's kind of between, instead of pi's over 4, which will get us sine over cosine, which has the same value, because tangent is sine over cosine. So we really want a square root of 3 out. So that's kind of got to be between a pi over 6 and a pi over 3. So when in doubt, we can choose one. Let's go ahead and try pi over 3, which has the coordinate of 1/2 and root 3 over 2. So you have the square root of 3 over 2 all over 1/2. So square root of 3 over 2. Keep, change, flip your bottom. We can cancel. So we're at root 3. Meaning that anything with pi over 3 is going to be in our response, because again, we have plus or minus here. So we're looking for all variations of pi over 3. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And again, because some of these are just separated by your pi amount, so directly across from this 3 or pi over 3 is this 4 pi over 3, right? Directly across over here. So we could write pi over 3 plus pi n. And again, your next location is all the way here at 2 pi over 3 plus pi n. So directly across from that one should be 5 pi over 3. And again, these are just separated by pi here. And that's why you can get just add pi n. So now when we move on to factoring types, notice that you now have more trig functions in your equation. So again, kind of let's break it up as we would. How would we evaluate, instead of sine, let's just do x squared minus 3x plus 2 is equal to 0. Well, because it's a quadratic, we want to make sure that everything is set to 0. So everything is on one side. And then we would go ahead and factor. We're looking at factors of 2, so 1 and 2, which if they're both negative, that'll get us to -3. And if they are both negative but multiplied, that'll get us to a +2, which means we found our factors. So we look at x minus 1 and x minus 2 is equal to 0. Therefore, x is 1 and x is 2. We don't just have x's, though. We really have signs. So we can replace your sign, your x's with your sign. So sine minus 1 and sine minus 2 is equal to 0. Therefore, sine of x is equal to 1 and sine of x is equal to 2. So on your unit circle, where is sine equal to 1? Well, that is all the way up at pi over 2. Now, where is sine equal to 2? Well, this does not exist because it is out of bounds. Your range here needs to be between 1 and -1. On your unit circle with a radius of 1 and -1, that means that we can't evaluate some unusual numbers when it comes to sine and cosine. So for here, we only have one response at pi over 2. Let's try it again here. Now notice here you have sine and cosine. Everything is also not to one side. So again, what would you have done if it was written as y squared x is equal to x? Well, because you have a squared term, you also have x's. Let's go ahead and put them on one side. And then what would you do? Well, you have two x's. Let's go ahead and factor it out. Factor out a common denominator. not a common denominator, common factor, greatest common factor. So you're left here. So cosine, I chose x for cosine because cosine is your x value, and sine, I figured, oh, well, that would be a good y value because sine and cosine are not the same functions. So really, this is what you have over here. You factored out your cosine, or let's say if I started at the beginning, you subtracted that cosine to the other side, set it equal to 0. You then factored your cosine out, so you now have your sine squared on the inside minus a 1 is equal to 0. So now you get to evaluate. Cosine of x is equal to 0, just like you would when x is equal to 0. Well, cosine is of x is equal to 0 when x is at pi over 2 and again at 3 pi over 2. So again, if I'm using my unit circle over here, so this would be all the way here at cosine, right, at pi over 2, and again at 3 pi over 2 at 0. So for sine, right, just like if we had this one, that's a difference of squares, minus 1 and plus 1, or you could say, you could add it to the other side, and plus or minus the square root of 1, which is just 1, right? No matter what take you have on it, we're evaluating when sine is equal to plus or minus 1. So when sine is equal to plus 1, this is when we're at pi over 2. And again at negative 1, so at 3 pi over 2. And we can see that up here again, if I just erase this. Sine is 1 at pi over 2, and sine is negative 1 at 3 pi over 2. So this gives us the exact same answer for both. So when we go to write it, we only need to write it once at pi over 2 and again at 3 pi over 2. So let's have you try it again with 15. See if you can pause here. You'll notice that you have two cosine values. So let's go ahead and factor out one of those cosines. So you're left with 2 cosine of x minus the square root of 3 minus 0. Again, I'm just going to treat this as I would if I had something like this, right? We factored out your x, just one of them. So we have something like that. So now where is cosine of x equal to 0? Well, that, again, from your previous, would be these two locations. The other two, when we have 2 cosine of x minus the square root of 3 is equal to 0, treat it as we would from your previous problems, right? Add your root 3, divide by 2. So where is cosine equal to root 3 over 2? Well, that would be at pi over 6 and again at 11 pi over 6. So you have 4 responses here for your unit circle. And again, we're just kind of evaluating at 0 to 2 pi. Again, I would probably do where it's not including 2 pi because that's a little redundant. Let's try it again one more time here. Let's go ahead and subtract the 1 to the other side. Oops, minus 1 is equal to 0. Now treat it as you would if we had 2x squared plus x minus 1 is equal to 0. Well, this isn't simple factoring, it's complex, right? So we're looking at factors of 2 times negative 1, so negative 2. So that's 1 and 2. And we want a positive x value here. So that means 2 is positive and 1 is negative to get a positive 1. And when we multiply, we get a negative 2, which again, that's what we had here. So we get to break up your middle term as negative x plus 2x minus 1 is equal to 0. Factor out a GCF or group. So you get 2x minus 1. And if that's the same thing that we want in your parentheses, we can just factor out a positive 1. That way it doesn't mess anything up. So you get x plus 1 and 2x minus 1 is equal to 0. So our x's are really our sine. So we have sine of x plus 1 is equal to 0. Oops, sine of x plus 1. And 2, sine of x minus 1 is equal to 0. So where is sine equal to -1? And where is sine equal to 1/2? Well, this is at 3 pi over 2. And this is at pi over 6. And let's see, 5 pi over 6 to remain positive. So these should be your responses. Again, notice how we kind of quickly breeze through factoring. Please watch chapter 1.3 on how to factor just about everything. So hopefully you found that video informative and can run through the remainder of these. Again, I'll show your answer key here and here.